Okay, parents, time to talk a little multiplication. I'm going to spend some time on multiplication because it's one of the topics that's probably the most unlike the way we all learned it in school. And hey, again, I know there's a parent letter that comes with the packet, but I think there's some things that I want to kind of specifically explain that aren't so much in the parent letter. I'll first start with just kind of the traditional approach to multiplication that we're most familiar with. That would be here where you're looking at a problem 75 times 84. And the setup, I think we typically refer to this as the traditional method where you're going 5 times 4, that would be 20, carry the 2, 4 times 7, that's 28, plus 2 is 30. And then we want to take our tens digit here, 8 times 5 is 40, so we do a 0. Now we've got to put our place value holder in here for the tens digit. Carry the 4, 8 times 7 is 56, add the 4 is 60, okay. And then add these two subtotals together, and that would give us 6,300. Okay, so that's the traditional approach. I think we're all used to that. There are definitely some things in there that are confusing for kids, very traditionally so. You may have in the past few years seen something called the lattice method. Okay. And that would be to set the same problem up in a grid. Now, I'll tell you, the first time I saw it, it caught me off guard. It was funny to have a kid this year when we started going over this, as we were talking about how to multiply, and she says to me, has something to do with some grids and some lines and so on and so forth, which again I think kind of goes to a kid's confusion with understanding these different processes. So here, to explain what the process is, you're setting the numbers up, and you're going to do each problem as an individual problem inside each one of these boxes here. So to start with, I've got 8 times 7, so this would be 56. 8 times 5, the subtotal here is 40. Now 7 times 4 here is 28. And then 5 times 4, finally in the final box, is 20. And then kids are to come through here diagonally and get their answer. So here they're going to add diagonally here. This would be a 0 in this answer. Add diagonally through this number, this row, and you get 8 plus 2 plus 0, which would be 10. So you have a 0, carry the 1. And adding diagonally through this column, 6 plus 4 plus 2 plus 1 is 13. So now here's the 3 in your total, carry the 1. And then finally this last column, you have a 5 plus the 1, which would be 6. Get 6,300. Both of these methods, I think for many of us, not being familiar with lattice, we look at that and say, what in the world is going on? Okay, and I think it's just important for parents to understand that many kids see both of these the exact same way, and they just don't have a clue. Some of them remember it, some of them don't, but they see both of them purely as a formula, and it's only their memorization of the formula, not really that they have any sort of number sense or anything else. The method that I'm going to focus on is different, okay, and it is taught, I'm not making it up, it's also taught in the everyday math. It's called a partial products method, okay, and I'm going to use a smaller problem as an example here. Okay. So, problem something like 56 times 3. I want them to really focus, instead of on a formula, I want them to use their problem solving skills and their estimation skills to attack this problem. And so instead here, they might not know 56 times 3, but they can use something that they do know, and they say, hey, well, you know, Mr. Irby, I do know 50 times 3. Okay. And you might recall from a few recent sheets that have come home where we've been practicing these problems, recognizing the patterns and saying, hey, these are all problems that are just from our times tables, our times facts. So if I could turn this problem into something that resembles that, then this problem becomes easy. Okay, so here is the first step in that, hey, this is something that I do know. I know that 50 times 3 is 150, and I don't have to do a ton of thinking there. Okay, and then kind of the where to from here. Now, we do have some kids that naturally, when they see a problem like this, will approach it still from the addition method, and so they would see that and they'd say, okay, well, how many 50s of that, and they would add them all together. Now, that's an acceptable way in terms of problem solving, but hopefully the kids will start to see that that's not the most efficient method. So here, you may have some kids that will look at this and say, well, then can't I add 6 more 3s to this? 3 plus 3 plus 3, and they might do that, okay? And it's an acceptable answer, but what we want to have them see even more readily is that, hey, if you've got to add 6 3s, isn't that the same thing as just adding 6 3s to that, a total of 18, and now you have your 2 subtotals, and you have 168 here because you're going to add those two together. Okay. That is what we call partial products. We'll be focusing heavily on that. Now, why I like this, again, because it's a lot more intuitive, it's using a lot more number sense, but even more importantly, as they go forward in their mathematics, okay, this problem, when I taught 7th grade, would have looked like this: 3 times 56. Okay, and we would recognize that this can now be written using the distributive property. Okay, so they would look at this and they would say, hey, instead, why don't I write this as 50 plus 6? And this becomes much more of an algebra problem. And so if they understand this first method, they are already tuned in to the underlying concepts of the distributive property, FOIL method as we go forward. So unlike the traditional mathematics and the lattice method, this method lends itself to all the mathematics that they'll see going forward. Okay, so this would be, again, kind of why I'll be emphasizing this as opposed to the other two. Not that the other two are wrong, and I won't be telling kids that they're wrong, but we will emphasize things that are more efficient than other methods. For kids who are going to need some more challenging problems, this approach lends itself to some other problems. So you might have even seen on last night's homework, kids were asked to look at, for some of the kids who took challenge problems, look at consumer applications here, so shopping where you have opportunities to use partial products. Okay, and kids who did this, now what I was shooting for was an answer similar to this, where a kid took this item, an item that was $2.23, they had 3 of them, and so they said, hey, I know my 2s, so $2, if I had 3 items at $2, that'd be $6. Then 60 cents or 20 cents a piece at 3 would be 60 cents, and then the 3 cents would be 9, and add those together for $6.69. When we looked at how kids actually did that last night, we had some who attempted it the traditional way, and again, that was not marked wrong, although we did have a lot of kids who had difficulty explaining this in class, and you can see there's not much work shown here. They just kind of muscled their way through it. We had some kids who were still in the mentality of adding it, and again, this was not marked wrong. Just as they go forward, they're starting to see that this is a little less efficient. And again, some other creative ones that were still in the addition method. So I'll be sending this home. I wanted people to understand what was being asked. Again, my focus will be on this consumer piece. For some kids, as they go forward, not only will I ask them to do this consumer part, but we'll start to look at problems that when they're using the distributive property, we'll also be using subtraction. So here's an example of a kid who used a distributive property with 3 digits, okay, and added these together. Okay. And a little bit later, you saw this student was asked to do a situation. Again, this is a very typical consumer situation where using the distributive property, they could say, hey, that's $2 and then minus the 1 cent. So it's a slightly different variation of this distribution problem. So that's about the approach. I know it took a few minutes to explain, and if you're still listening, then that's great for you. If you have any questions, as always, give me a call. But that's about what we'll be looking at the next couple of the next couple of weeks for multiplication.